labs. So vision sensors, how we see, how a control system sees things. These were non-existent a few years ago. Of course, we've had cameras for a long time, but how do we integrate cameras into being sensors? So we know what a sensor is, and we know we looked at position sensors, speed sensors, weight sensors, and looked at counters, pressure, flow, temperature, light. We've looked at gas levels, liquid levels. We've looked at orientation, shape, and size, which is what we're fixing to look at, and then we've looked at proximity. So orientation is the way things are placed, right? How they're oriented, and of course shape and size. So basically, to understand a vision system, you got to understand how cameras work and how TV works and how video works. So basically, the way these things work is they do scans, and they'll come in and they'll do what we call, they have a horizontal scan rate, and it'll scan across one line, and then it'll drop down and do the next line, and it'll drop down and do the next line. So basically, when they specify video like 800 by 600, they're specifying how many pixels are on a line. And then, of course, this right here would be the number of lines. Now, what is a pixel? Does anybody know what a pixel is? It basically tells you what it is. So pixel is a picture element. And in the old days, of course, this was in our eyes. What can our eyes see? We have cones and rods. I can't remember which one, but one of them looks at color. And basically, the primary colors we look at is red, green, and blue. And then we have rods, or I don't know the other one, it looks at shades of gray. So one of them is our black and white sensors, and then one of them is our color. But basically, colors consist of three things, and you can actually see this on a screen. I wish I could show y'all this. But your screen, in fact, you're looking at my screen, and I don't know if I can blow it up big enough or not. I might can take a picture and blow it up. But we basically deal with these little old triads. And what we would do in class is I would put my microscope up here and let you look at these things. And these things have little old tiny triads, and they're usually rectangles now. And they're red, green, and blue. But what they are is they're on a black background. So what we can do is, if we know the size of the pixel, and then we have a pixel is made up of these. So your screen has resolutions. I don't know if we can still do that on Windows, but we'll go to I'm sorry, this is Windows 7. I know we could do it on Windows 8. I'm sorry, XP. But we can come up here and we can go to screen resolution. So right now I'm running, so this would be the number of pixels per line. This would be the number of lines. That's the resolution I'm using for this screen, and that's the way TVs are rated. Another thing they're rated is a physical size, like, a 36 inch or no, that's nothing now, like a 68-inch TV. What that is that's a measurement from one corner to a diagonal corner here. So this is the way they set those sizes of the screen. Then we also have, I don't know if we can't do that anymore, but so these are the pixel resolutions available to me. We can't change it on the old Windows XP machine. You could actually change the rate that the pictures are actually flashing on the screen. In the old days, we used to call that the refresh rate. It was down to 30. So originally when they started out, they was using 30 pictures per second or frames per second. Then they moved up to 60. And the problem with the 30 frames per second is a lot of people, even though they couldn't see the different pictures. So video, guys, is a group of pictures. And what we're doing is we're flashing the pictures at a certain rate. And our eyes actually takes these still images and we see them as something, and if the pictures change slightly, then what that means is that it's going to appear to us like it's in motion. The old, what would they call them, kaleidoscopes, that's all they were, where people would thought that was amazing, where they'd look down inside and it was just a bunch of pictures on a wheel and they'd turn the things on the side and things would look like they were in motion. Well, that's exactly the way TVs work. That's exactly the way all our videos work. Movies work on the same way. They're flashing individual pictures at the screen, and then if the pictures change slightly, then what that means is it looks like these things are in motion to us. We used to do this and make a guy had a movie camera where we could still frame them, and what we would do is we would be out there sitting on our butts, and he'd take a picture and we'd move a little bit and take a picture and we'd move a little bit, and then when we put all the pictures together in a video, it looked like we were moving. So when y'all seen those type of things happening too, and still animation, clay animation does exactly the same thing. They take individual pictures and they combine them together. So we have a rate that we take the pictures, and then it's called the frame rate or the refresh rate, and then we have a number of pixels. Now notice what happens is I have all the way down to 800 and 600 available on this screen because it's a laptop and it's fairly old. But what they're doing is they're taking these individual little triads is what we call them. And what they're doing is they're taking those triads and they're grouping them into squares. These squares are what we call a pixel. So a triad would be one of these. Would be a red, green, blue, and then we take those and we group those into squares now. In the old days it wasn't, but now everything's digital. So we group these into squares, and these squares are what we call a pixel. So a pixel is definitely a group of one or more triad. So the best your TV can do, or your computer screen can do, would be one triad, and that would be the maximal pixel resolution that you would have. Okay? And then, of course, most computers give you the ability to zoom in and zoom out and change the pixel resolution on the fly. So that's what a pixel is. If it's in color, if it's gray, if it's shades of gray, so it depends on what type of camera you run into. Our cameras that we have on our robots over there, these are colored cameras. So not only can we make the camera respond to color, but we can also make it respond to shape and orientation. So the processing power now, guys, is in the camera. And it was amazing to me. I've seen this thing where they have these cameras up here, and then they're shooting like potato chips across a gap. This is actually higher, across a gap. And these cameras, it took them a long time because vision was so slow. Cameras were so slow. Like I said, refresh rates of 60 times a second. Now the cameras are really, really fast. And they have these cameras mounted up over here, and they have all these little air jets up here. And when these potato chips fly over, if it don't match what they're supposed to match, a little puff of air will come out while it's in motion, flying across the gap and blow the bad ones down into the gap. Y'all would have, they do that with fruit, different types of fruit too. So if I know this, if I can set this thing up in a metrics where I have rows and columns. So we know the pixels. We know what pixels we're scanning. So the pixels would be the rows. So up here I'd have 640 rows, right? And then if I've got the pixel, if I know what pixel you're on, then I can tell by the camera when this image comes back, it's going to be coming out of this, and all of a sudden it comes up and starts doing this when it sees something. Well, I can tell by that now exactly where things are. I can not only tell how they are, but I can also come in here and tell by the pixels, since I'm doing rows and columns, right? You understand that? So the actual number of pixels, this would be the rows. I'm sorry. Yeah, the number of pixels, I'm sorry, would be the columns. And then, of course, the number of rows would be how fast these scan lines goes down. So since we know that information, the controller knows where that camera's at, then we can actually get an electronic image of what's out there. So not only could we tell where it's at, we can tell where it's oriented, we can tell what color it is. So we used to have, I wish I could find it, we had a program for the ABB robot where we could take all these blocks and put them out there. We had to spread them out because of the size of the gripper, and the camera would actually go out and look up and find the blocks that had this on there. So it would actually come up and spell out robot, which was pretty neat. And it did it fairly fast. And like I said, the cameras we have now, so it's the cameras that we have. Comdex is one of the big camera makers. That's who we have. And these are intelligent cameras. They come with a piece of software where you come in and literally put what you want out there. Where you want out there, you tell it to memorize that, and then you tell it the angles, like 360 degrees, which means now that camera would not only be able to find that R, it would be able to find it no matter what orientation it was in. So these are the way our vision system works, guys. Very smart cameras, but somebody's got to go out there and program that camera. Somebody's got to go out there and program it. So we got a software, I can't remember what it's called. It's called Vision something, that comes with the Comdex cameras, that you basically mount the camera, you mount it at the right amplitude, and then you come back and you calibrate it. So we have a calibrator that we can put down out there. It's a certain pattern. I wish I'd have brought it over. I'll try to remember to bring it over next class, that you put under the camera, and the camera knows, and the computer inside the camera knows that pattern. And so now it can justify the focus, it can get the size and everything, the focal lengths and everything for the camera. Then what you do is you put the item you want it to recognize out there, and then you tell it to recognize it. You can tell it you can say 0 degrees, and that way it's got to be oriented exactly the same way. Or you can say like 360 degrees, and it would literally come in there and be able to detect what angle that was in, which is very, very popular. So cameras are becoming more and more predominant. I don't know if y'all got any out at GatStump or G-Stamp, whichever one you want to call it. Y'all have any camera systems out there that y'all look at, or they have, that looks at orientation? A lot of things like that, we orient it the way we want to by having what we call these jigs that the part moves into. It'll have to fall into the jig exactly the same way every time, and it orients it for us, and we clamp it down. We do different things. I think a lot of the cars, the frames have pinholes in them, and they move them up and move them until these rods can come up to the pinholes, and so that's probably the most popular way, is to mechanically orient it. because camera systems cost a lot of money, and of course somebody's got to be able to program these things. So that's what we're saying. We can literally find shapes, and these would be programmed into the camera now. And of course, I've had some experience programming cameras for robots, and the only ones I've done is the Comdex cameras. I think we got one over there, but I'd have to find the software for it. We got one that came with the Amateur line. So guys, that's all there is to vision scans. They're just cameras. We mount them so they can see the parts that we're looking at, right? Then we program the cameras, and then it sends that information in a XYZ. So the camera will send an X, Y, Z. So orientation, front would be X, and then back and forth. This is going to be Y, and then Z would be up and down. Which is what robots use. A lot of times it's just X, Y. And then it'll give it in a coordinate system with Y coming first. And basically it would give... and then send that information into your controller or your PC, and then you would have to analyze what that is. So we okay? Anybody questions on vision sensors? Very simple. I mean, they're not simple. They're very complex. But now the camera does just about all the work for you. All you got to do is learn how to run the application that programs the camera. And then the camera would send the information back to your computer on how things are oriented. Our camera gives us an XYZ, so the robot knows how to orient the gripper. It's really neat to watch that thing. So it'll actually orient the gripper and go down and pick up the block and then spin it around and set them down to spell robot. I've got that video. Somewhere. But anyway. So any questions on vision sensors? So everybody know what a pixel is. What's a pixel?
A picture frame.
A picture element. It's a picture element. Yeah.
Okay.
So it's a little part of a picture. And then the screen resolution would be how many, we call these triads, by the way, because there's 3 of them. So it's how many triads you put inside a pixel. So a pixel is at least 1, so that's the best resolution. And of course that's the best resolution. And sometimes even TVs, you can see it start pixelating when you're having problems with your bandwidth. You can see the actual squares start popping up on the screen in front of people because it's the bandwidth and it can't update or get the right pixels up there. And then we come up here and we take these, and then a pixel would be 1 or more triad. So the best you can possibly do and what we do is we turn on different colors inside here, red, green, and blue, and we turn them on, and then our eyes blend that together. And I wish I could show y'all this. It's white. It's got all 3 of them turned on, and they're turned on real bright. So the way we do it in computers is we can't really do black. So that's why our eyes have shades of gray. I can't remember if it's cones or rods. Y'all can look that up. That's not going to be on our test. But one of them, we have 3 for each colors, and we got thousands of them back there. And then we got the other one, which is cones or rods. All it does is see shades of gray. So this is why when you have your color printer, you can't do black with red, green, and blue. So you always have to have a black cartridge that you put in your printer, or a black or one cartridge that's got black in there. So basically the way computers work, or the cameras work, is they're taking it against a black background that's built into the camera. It's got all these charge coupled devices, CDC devices now. Charge coupled devices. These are actually semiconductors that absorbs light. And then what they do inside the camera in front of each CDC is they'll have a lens, and they'll have a red lens, a green lens, and a blue lens. So the CDC can't distinguish between colors. All they can do is just give you a different output depending on the amount of light, but then they filter it through a lens. And so each charged couple device, and that's big in cameras, by the way, and y'all can look up CDCs. It's pretty interesting. It's kind of like a photovoltaic cell. It works on the same principle. Used to we had Vidicon tubes in old cameras. These were actually tubes that would sense the different pixels. But now you probably won't run into that anymore. But these use what we call CDCs, or charged couple devices, and these are just little semiconductor wafers, little tiny things. So we'd have to have one. We would have to have one CDC for each color for each triad inside a pixel on the camera. Then it scans it at one line at a time, sends that information to your TV one line at a time. Then it comes up, and it does it at a rate that's unbelievable. And then what it'll do is it flashes it in what we call frames, which are individual pictures. And then our eyes just blend those individual pictures together. And that's the way we can compress video. So all these MP3s and MP4s, which is videos, is basically what they do is they don't send repeating pixels. They only send pixels that change. So the next frame would use the same background if nothing's motion, and then they just change the pixels that's changed. And that's the way they compress. That's the way we compress. Is any pixel that don't change, they don't retransmit it, and every pixel that changes, they transmit it, and they throw the previous frame up there, and then they'll put the changing pixels in there. And that's what MP4 does, which is really, really, really revolutionized digital information. Because if you think about this, we're doing 1024 by 1024. If we do 1024 by 768, that would be the number of pixels. And then on our computer, we're trying to do the number of colors. So if you do it with 32-bit color, that's going to be times 2 to the 32nd. And this is how much memory your computer would be trying to update just to update the screen. I should know this, guys. 2 to the 32nd is what, 16,777,216. Let's see, 2 raised to the 32nd. No, I messed that by a long way. It's so this is how many pixels, and then you would come up here and you would divide that by multiply that times 64. And then you'll multiply that times 480. And that would be the number of pixels. And then you would divide that by 8, which is the number of bits in a byte. And that's how much memory it would take to do that if they didn't do compression. So you can see that's a lot of memory. Did I do that right? 2 raised to the 32nd, which would be 32-bit color. Then we multiply that by the total number of pixels. Would be 640 times 480, which would be that big number. That's not right. For vision sensors. So we need to understand pixel resolution. That tells you a lot about your TV now. Of course, we don't control the refresh rate now, how fast the pictures are being popped up on the screen. But our eyes can only update so fast. And this is what people would go out and set up their computer for 64-bit color, and we can't even see that many colors. And what they're doing is they're wasting tons of memory, and they don't understand that. So, I usually use 16-bit color, which is about best my eyes can do, which would be 2 bytes per pixel, 2 bytes of memory per pixel. So any questions? Anything you want me to go back over?